This video is only going to be about square roots. So let's start with simplifying. There are multiple ways to simplify a square root, but this is the way that I like to use. If you know of a different way, then you're welcome to use it. So to simplify square roots, use a factor tree to break down the number under the radical. Radical means square root symbol. Move any pairs you have, groups of 2, in front of the radical. Leave any unpaired numbers under the radical. So the way one of my teachers taught me was, if you have a date, leave the house, so your pairs move in front of the radical, and if you're single, stay home. So anything that doesn't pair up stays underneath the radical. So let's do some examples. Example 1, simplify the square root of 72. I'm going to use a factor tree to break this down. So you think to yourself, what two numbers can I think of that multiply to 72? There are a lot of numbers you can use. You can do 2 and 36, you can do 8 and 9. Whatever you start with, it doesn't really matter. We're going to end up with the same final answer. So if you want to use 2 and 36, go for it. If you want to use 8 and 9, go for that. I used 2 and 36 in my notes online, so that way you can see a different factor tree still ends up with the same exact answer. So 72 breaks down into, I'm going to use 8 and 9 for this example. Broke that down. 8 can break down into 4 and 2. 4 can break down into 2 and 2. And none of these numbers break down any further. But I need to go back and check 9 can break down into 3 and 3. So step one, use a factor tree to break down the number under the radical. Done. Now move any pairs out front and leave any unpaired numbers underneath. If you have a date, leave the house. If you're single, stay home. It doesn't matter how you pair them up. I can choose to pair up these two 2s, these two 2s, or those two 2s. It doesn't really matter. The fact is that I have a pair of 2s that get to leave the house on a date. And I also have a pair of 3s that get to leave the house on a date. This 2 doesn't have anyone else to pair up with because these are already paired, so the single 2 stays home. Now, multiply everything together that's on the outside and multiply everything together that's on the inside. 2 times 3 is 6, and there's nothing else underneath the radical here, so this is just a 2. So the square root of 72 equals 6 times square root 2 in its most simplified form. Let's do another example. These are going to have variables in them. The variables are these x's and y's, any kind of letter. So we're going to treat the numbers the same way we did before. 486 breaks down into 2 times 243, or 6 times 81, or whatever pair of numbers you can come up with. I usually go through 2, then 3, then 5, then 7. I try and break them down that way. So I'm going to pull out a 2. 2 times 243 is 486. All right, 2 doesn't break down, but 243 does break down. I can pull a 3 out of that. 3 times 81 is 243. 3 doesn't break down, but 81 does break down. You can use 9 and 9, and then you automatically have your pair of 9s to pull out front. Or you can use 3 times 27, and then 27 is 3 times 9, and 9 is 3 times 3. It doesn't matter what you start with, but you should end up with 5 3s and a 2. If you have a date, you can leave a house. So I have a pair of 3s to go on a date. I have another pair of 3s to go on a second date. And then I have this 5th 3 that doesn't have anyone else to pair up with, so it stays underneath. I also have this 2, don't forget about it, that doesn't have anyone to pair up with, so it stays underneath. So the numbers are the exact same way we did in example 1, but now for the variables, I like to write out 5 x's. And now pair them up just like I did before. So I have a pair of x's, and a single x. So this would be x squared. I have 2 circled groups, so 2 dates that get to come out, and then a single x underneath. Same idea for the y. It's y to the 6th power. So if I write out 6 y's, pair them up, I have 3 pairs, so that means y cubed comes out front. Ooh, I don't have a lot of space. And there aren't any y's, single y's, left to stay underneath. For these problems, you should not end up with an exponent on any letter, any variable underneath your square root. If there's an exponent there, you did not fully break it down. So, final answer, multiply everything together. 3 times 3 is 9x squared y cubed. Underneath, 3 times 2 is 6x. Okay, that is simplifying square roots. Let's talk about multiplying and dividing. So when you're multiplying square roots, you multiply the numbers in front. This number here, if you have multiple ones of these, multiply them together. Then you multiply the numbers under the radical together, and then you'll have to simplify your radical just like we did in these previous 2 examples. All right, let's do this example. The 2 and the 4 are in front of my radical, so 2 times 4 is 8. The 3 and the 6 are underneath my radical. 3 times 6 is 18. Now break down your square root 18 just like in example 1 and 2, or however way you learned it before. 18 is 2 times 9. 9 is 3 times 3. I have a pair of 3's that can come out front and a single 2 to stay underneath. Don't forget you originally had that 8 out front. So I will multiply 8 times 3 is 24 square root 2. Let's do one that has variables in it. Okay, any numbers that you have in front of your square root, you want to multiply them together. So all I see is this 4, there's nothing else here, so I just have a 4 on the outside. Anything that you have underneath your square root, multiply them together. So I have a 5 and a 15. 5 times 15 is 75. I have this v8 and v cubed. Add your exponents together. We learned that in a previous class. And I have y to the 6th and y to the 4th power. Again, add your exponents together. When you're multiplying, you add exponents. So step 1, 4 stays on the outside. Step 2, multiplied everything underneath the radicals together. Step 3, break that down. If we break down 75, it is 5 times 15, because those are the 2 numbers I multiplied together. You can use 3 times 25 also, if you'd rather do that. 5 doesn't break down any further, but 15 is 5 times 3. That means I have a pair of 5's to come in front with my 4. And I have a single 3 to stay underneath. Now deal with your v's and your y's. All right, I have 11 v's because v to the 11. So I'm going to circle my pairs. 1, 2, 3, 4, 5 pairs, and this single v to stay underneath. So 5 pairs come out and a single v stays underneath. I'm going to write out 10 y's and pair them up. 1, 2, 3, 4, 5. So again, we have y to the 5th power comes out, and there's nothing left underneath. My final answer here, 4 times 5 is 20, v to the 5th power, y to the 5th power, square root of 3v. If you're simplifying fractions and you see something like this, you can simplify it like a normal fraction, but only simplify a fraction if both numbers are not part of a square root, or if both numbers are part of a square root. Hopefully that somewhat makes sense. So in this example, 4 and 10, I could take a 2 out of both of those. I could take a 2 out of the 6 also, but the 6 is under a square root and these other numbers aren't. So I do not mess with the 6. Do not switch back and forth between, these are called coefficients, numbers that aren't part of a square root, and the radicands, numbers that are part of a square root. So don't mix them. Similarly, the square roots here, 15 and 6, they're both under a square root. 15 and 6 can both have a 3 taken out of them. Okay, so I say that though, if you see this next example, the directions would be to simplify. I don't have any coefficients here, so it makes it a little bit easier. They're both radicands, they're both underneath a radical symbol. So I can either just straight up say, okay, 4 over 100 is 1 over 25. Now let's simplify this. Whenever you are taking the square root of a fraction, you can distribute the square root symbol to the top and to the bottom, and that'll make it easier because the square root of 1 is 1 and the square root of 25 is 5. That is one way to do this, is to straight up simplify your fraction because they're both under the square root, distribute, and then take the square root of each piece. There's another way to do it, and the other way to do it is to start off by distributing your square root. So I could have the square root of 4 over 100. I could, in this case, go on and distribute my square root, and then try and break down your square roots. In this case, the square root of 4 is 2, and the square root of 100 is 10. And then 2 over 10 is 1/5. For these problems on your homework, they are going to always end up being whole numbers. That's not true in everyday life, so if you plan to take more math, know that when you distribute the square root, you may have to actually break down your square roots like we did in examples 1 and 2, and you may end up with something messy like this that you then have to try and simplify. If you plan to take pre-calculus, Math 11-13 with me, we will do some things where you end up with messy fractions like this. But for Math 11-11, we're just going to have nice, pretty whole numbers. Okay, for example 6, same idea. I could go on and distribute my square roots and then try and simplify everything like I did here. If I did that, the square root of 18, the square root of 50. To save us time, that would be 3 square root 2, and that would be 5 square root 2. The 2 square root 2's cancel each other out, and this is 3/5. Or you could do it the way I did this first problem and just say, well, 18 over 50, both of those I could take a 2 out of, and then I'd be left with 9 over 25. Now it looks a lot simpler if I distribute my square root. The square root of 9 is 3 and the square root of 25 is 5. So either way you get the same answer. Just know for these problems they're always going to be whole number fractions. You're going to get rid of your square roots completely and just do whichever method seems easier to you, or sometimes that might change depending on what the problem gives you. All right, last thing we're going to conquer in this video here is adding and subtracting square roots. So when you're adding and subtracting square roots, you can only combine like terms if the number under the square root is the same. So what I mean is, in this example here, I have a square root 2 and a square root 2. I can add those two together. I would say 5 plus 3 is 8 square root 2. But I also have this square root 3 here. It's different from square root 2 because 3 and 2 are different numbers. So I have to just leave it as is. I can't combine it with anything because there's no other square root 3 there to combine. So this would be my final answer. It doesn't matter if you put the square root 3 piece first or if you put the square root 2 first. Either way, it's the same idea. But for the most part, when I give you problems like this, I am not going to straight up give you the nice simplified square roots. I'm going to want you to first simplify them and then combine like terms. So right now in example 8, I can't add anything together because I have a square root 98, a square root 2, and a square root 18. None of those are the same thing. None of those have the same number under your square roots, so I can't combine like terms. But if I were to break this down, the square root of 98, 2 times 49, 7 times 7, I have a pair of 7s that can leave the house and a single 2 to stay underneath. 2 doesn't break down, so this is going to stay 15 square root 2. And it's okay that I didn't break something down. And then my 3's come out and my 2 stays underneath. So this is, don't forget that 5 was out there originally. 35 square root 2 plus 15 square root 2 minus 3 square root 2. Oh, they're all square root 2's. That's nice. So they're all square root 2's. I just have to add or subtract all of these numbers together. 35 plus 15 is 50, minus 3 is 47 square root 2's.